Welcome to Ace Industries. My name is Roddy Rossborough. I'm the General Manager here at Stren-Flex Slings. Today, we would like to present to you the criteria for removal of synthetic web slings during a sling inspection according to OSHA and ANSI standards. After we review the criteria for removal, we will demonstrate the effects of certain types of damage on synthetic slings. But first, let's talk about some of the basics of synthetic slings. Web slings are typically made out of either nylon or polyester material. Polyester is recognized by a single blue strip down the center of the material. Nylon has no marking. The two main differences in the material is the stretch factor and their reaction to chemicals. Nylon stretches about 10% under full working load, and polyester stretches about 3%. Also, nylon reacts better to most ethers and alcohols, while polyester reacts better to most acids. As a general rule, with both types of materials, there is a heavy-duty and a light-duty webbing. Heavy-duty web is the most popular. It has a breaking strength of 9,800 pounds per inch. Light-duty web has a breaking strength of 7,000 pounds per inch. These breaking strengths form the basis of our working load limit. The working load limit, or rated capacity, is identified on the sling's tag. The rating will be based on the type of hitch used. There are three basic hitches. Vertical is a straight 90-degree hitch that is rated at 100% of the working load. In a choker hitch, one eye is passed through the other, creating a choke around the load. A 90-degree basket hitch is simply double that of a vertical hitch. The rated capacity is the maximum capacity that the sling should be used to lift a load. Never exceed the rated capacity of a sling. Every new synthetic sling we manufacture has a 5-to-1 design factor. That means if a sling's rated capacity is 1,000 pounds, then the breaking strength will be at least 5 times that, or 5,000 pounds. This only applies to a brand new sling. Sunlight, abrasion, and everyday stress on the sling can diminish the sling's breaking strength over time. Again, never lift more than the rated capacity of the sling. Now that we have talked about the sling's basics, let's take a look at how a web sling is made. First, the sling is laid out and marked, and then cut. Then the sling is brought to the sewer for sewing. The sewer sews the load splice and the body of the sling. The tag is sewn on, and then the sling is ready for packaging. To make certain that our slings always exceed their expected breaking strength, Stren-Flex has quality control procedures and brake testing procedures in place to test not only the raw materials such as webbing and the thread, but we also test the workmanship of each sewer and the operating performance of the sewing machines. According to the Occupational Safety and Health Administration, or OSHA, synthetic slings must be inspected by a qualified person each day before use for damage or defects. A qualified person must also perform additional periodic inspections where service conditions warrant, as determined on the basis of frequency of sling use, severity of service conditions, the nature of the lifts being made, and experience gained during the service life of slings used in similar circumstances. Make periodic inspections of synthetic web slings at intervals no greater than 12 months. A good guide to follow includes yearly for normal service use, monthly to quarterly for severe service use, and as recommended by a qualified person for special and infrequent service use. It is recommended that periodic inspections be documented and the inspection records be maintained. What are we looking for in a web sling inspection? What is the criteria for removal of a web sling from service? First of all, the sling must have a tag, and it must be legible. There are visible warning yarns in domestic web sling material. These warning yarns become visible when exposed to severe abrasion or cuts. OSHA says no cuts at all. We're also looking for acid or caustic burns, melting or charring of any part of the sling, holes, tears, cuts, or snags, broken or worn stitching in the load-bearing section of the sling, excessive abrasive wear, UV or sunlight damage, knots, excessive pitted, corroded, cracked, distorted, or broken fittings, and according to OSHA, any other visible damage that causes doubt as to the integrity of the sling. There are many ways to help protect a web sling from normal damage. The most common is the use of a wear pad. A wear pad forms a barrier between the load and the sling. A very economical solution is to wrap the sling in Stren-Flex Gorilla Guard. Gorilla Guard is an abrasion-resistant material that we use to cover the entire sling or any part of the sling. Stren-Flex also manufactures slings with a patented webbing called Monster Edge. Abrasion-resistant fibers are selvaged into the edge of the webbing to protect the sling from edge cuts. If the application is severe, such as it is with lifting glass, we can use leather, thick felt, or even Kevlar as a wear pad. Now that we understand the damage we need to look for in an inspection, let's look at how this sort of damage affects the overall strength of a web sling. Now let's go to our testing facility, where our quality control manager will demonstrate the different types of damage in our test bed.
Hi, this is Mark. For this quality control exercise, we're going to use a standard 2-inch 2-ply heavy-duty sling. The vertical lifting capacity of this sling is 6,400 pounds. Remember, we're trying to achieve a 5-to-1 ratio, which would equate to a 32,000 pound breaking strength during this exercise for all slings that you will see. This example is a brand new nylon sling that you previously saw being made in this video. Notice the stretch of the nylon during the break test. You can actually hear the thread popping prior to the overall failure of the new sling during this test. Notice that this sling broke at the load splice, which is the weakest point of the sling. This sling broke at 32,500 pounds, which is above the targeted 5-to-1 ratio of 32,000 pounds. This next example is a new sling with a 10% edge cut. This time, the sling broke at the 10% edge cut, which was the weakest point. The sling made it to 18,800 pounds, which is well below the targeted 32,000 pounds. This resulted in a 40% decrease in the overall strength of the sling. This next example is representing a face cut. This face cut is only a slight cut on one ply the entire width of one side of the sling. face cut sling broke at 23,800 pounds. This resulted in a 27% loss of the overall strength of the sling. This next example represents a sling with heat damage. Notice the burn across the face of the sling. In this test, the sling only made it to 24,700 pounds. This result equaled a 24% loss in strength of the sling. This next example represents a 2-inch 2-ply with a knot. The use of a knot to shorten a sling is prohibited by OSHA. As the knot tightens, it actually cuts into itself, causing the failure in the sling. The sling with a knot tied in it broke at 13,000 pounds. This is about a 60% loss in the breaking strength of the sling. As you can see in all the examples, damage from normal everyday use can greatly decrease the overall breaking strength of the sling.
Thanks, Mark. We have discussed what types of damage to look for during a web sling inspection, and we have seen what the effects of this type of damage can do to the overall breaking strength of a web sling. OSHA standards are in place to protect us, and a good inspection program can save money and increase the safety of the employees that count on web slings to do their jobs. Thanks for participating in our presentation. Have a safe and productive day.